Are you ready to dive deep into the complicated world of cryptographic hashing functions? No? Good, neither are we. That's why here at Whiteboard Crypto, we break every complicated and confusing cryptocurrency topic down to their very basic levels and use analogies and stories to help explain them, so that the average person like you, who's not ready to fully grasp what the heck a cryptographic hashing algorithm is, will be able to understand it so well that you could explain it to your grandpa, or rather, you could show him this video and he'd understand it. So think of a cryptographic hashing algorithm like a magical black box, where you give it something and then it poops something out. A hashing function is just a system where you can put something into it and it'll output a hash. So we'll get into what a hash is in a second, but just know that we do need it. Now there's a ton of math happening inside this so-called magical black box, but essentially you give it something and then it does the pooping. In this case, Bitcoin uses the SHA-256 hashing function. Now there's many different types of functions, but SHA stands for Secure Hashing Algorithm, and 256 refers to the amount of zeros and ones that it has in whatever it outputs. So whether you put in your name or you put in the entire dictionary, what it poops out will always be 256 ones and zeros. Now our computers are really smart, so they convert these ones and zeros, the binary, to actual letters and numbers, which equals 64 numbers and letters. Now there's many different hashing functions, but Bitcoin uses SHA-256, and in this video we're going to focus on that function for examples. So let's get into it. Essentially, you need to know 5 main things about a hashing function. Number 1, you always get the same output if you give it the same input. Number 2, no matter how much data you give it, it always poops out the same size of output. Number 3, it is quick to compute. Number 4, you can't reverse it or predict the hash. And number 5, it's infeasible to find 2 hashes with the same input. So let's go back over these in a little bit more detail. Number 1, you always get the same output if you give it the same input. So if we give it, would you please click the like button below? It gives us warm fuzzies. Then it would output this. But if you did it again, it would give you the same seemingly random numbers and letters, but they will be the exact same. Now these numbers and letters are what we call the hash. And like I said, it's actually a bunch of ones and zeros, but we turn it into number and letters so we can look at it easier and it's easier to copy and paste. Number 2, no matter how much data you give it, it'll always give you a fixed output. So if you give it an A, it'll give you 64 numbers and letters. If you give it AA, it'll give you 64 numbers and letters. Then if you give it AAA, it'll give you 64 numbers and letters. And if you give it the entire encyclopedia, it'll give you 64 numbers and letters. And lastly, if you gave it my social security number, it'll still give you 64 numbers and letters. The black box is magical in this sense that if you give it a letter or a million letters, it'll always output 64 numbers and letters. Number 3, it needs to be quick to compute. So this would be a really good place to show you exactly what's going on inside this hashing black box, but it's very technical and not everyone who watches this video really needs to understand completely how it works. If you do though, here's an intro. See, it first converts your message to binary, and then it adds a single 1, and then it adds zeros until it gets to a multiple of 512 ones and zeros. Then it appends 64 bits, then it initializes hash values, and this is where most people will have to look up what initializing hash value means, and that's why I'm not going to explain the whole thing, because just look, message schedule, chunk loop, you don't need to know exactly how all these work to know how a basic hash function works. You just need to know that it basically does a bunch of math with the ones and zeros. Computers are really good at math, so that sums up our third point, that it needs to be quick to compute. And actually, most computers can do a few million of these each second. Number 4, changing the input just a tiny bit changes the output a lot. So basically, if you do SHA-256 of subscribe to our channel, you get this as the output. However, if you do please subscribe to our channel, you get this, which is entirely different. And lastly, if you change it just a tiny bit, we're just going to add an exclamation point. You get this as the output. And there's a reason we want a small change in the message to greatly change the hash, because otherwise it might be predictable, and that would break the security of the whole hashing algorithm. Number 5, lastly, it must be nearly impossible to get the hash of 2 inputs equal to the same output. In fact, currently there are no known 2 inputs that generate the same output in SHA-256. However, in MD5, which is a different hashing function that has a different magical black box and does different math, does have a few. For example, this input and this input both give us this. However, there aren't very many of these collisions found, and SHA-256 is much stronger than MD5. So people have actually been mining for years while creating billions of SHA-256 hashes, and no collision has been found. Maybe if you're lucky, you'll find it yourself, and you'll probably honestly win an award. But you just need to know 2 inputs rarely, if not never, come up with the same hash. So finally, what does all of this, a cryptographic hashing function, have to do with crypto or cryptocurrencies? is? Well, it really has to do with something called proof of work, which is the exact method we use to actually mine Bitcoin. You can watch my proof of work video about it, but essentially, here's what we're doing. Number one, we're taking a list of all the transactions that people want added to the blockchain. Number two, we are then adding a random set of numbers and letters to that transaction list. And finally, we are calculating the SHA-256 of that until we get an output that has a certain number of zeros. So in this case, because all I have right now is my personal computer, we're going to find out how to get subscribe with 7 zeros. Well, as we mentioned earlier, we can't predict what we need to add to it, so we'll just have to guess and check. Let's start with 1 and then go up from there. So we start with subscribe 1, and this is what we get. It does not end with a 0, it ends with a 6. Then, using some simple Python code, we can keep adding a new number at the end until we get a 0 at the end of the hash. For example, at subscribe 9, we get this, which has 1 0. At subscribe 45, we get this, which is 2 zeros. On try number 2864, we get 3 zeros. On try number 38,245, we get 4 zeros, and so on and so on. Until subscribe 326,032,489, we actually end up with 7 zeros. Now this is essentially what mining Bitcoin is, except instead of subscribe, the data is literally a list of people exchanging Bitcoin, like John pays Bill 5, Eric pays Robin 8, you pay me 20, and so on. And just to prove this, if you look at a recent Bitcoin block, you see that someone had to compute 19 zeros for the block to be valid, which my computer took 10 minutes to find 7. And as you saw, it exponentially took a lot more tries to get to the next 0. Now, there are actually hundreds of thousands of computers around the world guessing all these random numbers, and then once they find it, because we can pretty much make sure that they guessed and checked and didn't just predict it, we can be reasonably assured that they did put in a lot of work, and because of that, they probably didn't make a fake transaction. Anyways, I hope you enjoyed this video on the cryptographic hashing algorithm and how it works, and I hope you learned something about their purposes. If you did, please consider mining the like button and subscribing for future videos so that you can reward our hard work on these projects. We hope to see you in the next video.